Yeah, so oops. This is a really interesting program. I'm still figuring it out, but let's draw more or less a rectangle. So what we want is this shape like that. And sine is nice because it is smooth. It doesn't have these discontinuities. I mean, it's like, yeah, circles are really the opposite of these kind of discontinuity things. But so how can we get this? Well, this is just the cosine function inverted, right? With the cosine function, it looks like that. If you look at sine function, it looks like that. We want this guy, and we just flip it upside down, so we'll multiply it by -1, and then we scale to the number of well, cosine also, this is 0, so we multiply by -1, then we have to add 1, so it goes from 0 to 2, and we divide by 2. It gives us 1. So let's go ahead and do that. And yeah, this should probably go into a library later, but for now, again, let's just do that. So we're going to need at some point pi. That's about as far as I remember. Put 7 there and 8 there. I think these are all valid. Anyway, this is like a nerd EP thing, and I kind of suck at these memory games. But we'll test. Okay, I was right up to the 2. No, I was not wrong. Right. Yeah, so that's pretty bad. I've probably been writing that for a while. Okay. So we want a full cycle, and that's this. And we want to go from yeah, what we can do to avoid using those explicit casts is you just multiply by index here, and you divide by case stretch window size here. So that'll give us a regular cosine fitted to our window. And again, we have to multiply by -1. And we also have to take that result, add, let's do the add 2, no, add 1, and that gets us to 0 to 2. We just divide by 2. Probably some, I don't know if there's a better way to do this. This is pretty good. And you know, that should create the shape we're looking for. Let's try it. See if the cosine library is, I mean the math library is included. If not, we can just include math.h. It's not a big deal. Looks like it built. Konnichiwa, 僕の名前はキラです。No sound at all. No sound at all. So looks like this is returning 0 for some reason. Oh, we're not returning it. Shoot. Yeah. Yeah, actually. So now we know what the default return value is for our compiler. Let me. こんにちは、僕の名前はキラです。So, sorry about the mic. Sounds pretty gravelly. It's very slow. Kira des. Kira. It's the same pitch, right? But something the way we're doing is not ideal. And computing the cosine value repeatedly, I mean, we could trust the library, but that's not a good idea. It's probably not cached because we're specifying these arbitrary values. So we probably want to compute a table since this is going to be constant. And we could do that at some point. The quality is still pretty bad though, and I'm not sure exactly why. I do want to fix one thing before I start to nitpick the quality though. So I'm going to commit now because this is a reasonable point. Yeah, so actually the code looks not bad. Again, we can refactor things later, but right now this is a reasonable state. I'll do a quick diff, see what we worked on today. Yeah, some formatting issues. Yeah, and we added this stuff to filter audio mixer. So it's not a whole lot. So we'll call this fix bug in time stretcher for pitch shift effect. Still midway through implementation. Works, but still midway through. Yeah. And I just push it because yeah, wait. Yeah, it's good to push it. I can always rebase because this is my repository. Yeah. So, what else do I want to do? Oh, yes. Huh, it's taking an awful long time to push that. There we go. Yeah, I want to look at why I can only use 1/2 of... I'm limited. Well, when I stretch the object out, I need to be able to write more than the original sound. So I'll need more buffers, and I think effect entity is controlling this. It could also be the... No, it's effect entity. It has to be. So amazingly, we're not using any threads or anything, or we're just blocking until the effect has been processed, and magically the iPhone's fast enough. And later that definitely needs to change. once we start doing effects that analyze pitch, for example, there's going to be, I mean, essentially, it'll get a lot slower, and we can't do these kind of things. So I'm looking on the stream now, and it looks pretty crappy on Justin TV. Especially when I move around because the encoder starts tweaking out. And that's kind of sad, but I guess I'll have to look at it after. But it looks like a lot of dropped frames. So if that's the case, I'm just going to stop it now. Well, I'll let it go. Fortunately, the YouTube quality will be unaffected because it's offline. Yeah, so when we spit out an entity, that means that's talking about the visual part, but I'm pretty sure it allocates, it gives the sound. No, it doesn't. So this is output entities being allocated, and we don't give the sound right away to the output entity, which is interesting. That is interesting. So let me look at where we do that. So this creates the entity. This creates the initial velocity, and that adds it. Here's where we do it. Once we spit it out, we add the buffers. So the self-process sound bit, once we've added the input sound and processed the sound, I see. Yeah. So let's look at process sound. Yeah, so our process, this doesn't get called by the subclasses. Yeah, so we need a tail stub in this class, right? Yeah, the out buffers here. They need a cleanup, like right here. And we can just say out buffers dot, no. We just say self, instead of process sound internal, we say process sound finish, because there might be cleanup. Like in the case of pitch shift, that's when we want to add the remainder. And we want to do that until the sound has finished. So this is going to require editing the H file. So yeah, it looks like I'm watching the stream on the other side and it looks really crappy. I apologize, but I'm working on getting the encoder at a reasonable level where you can still see the text and it doesn't bog out all the time. But anyway, we need this process sound finish call. That'll be a virtual method. Well, I'm a C programmer, C++ guy, so I think of virtual, but it'll just be